We have with us Jan Liphardt, founder of OpenMind. Thanks for having me here at your San Francisco office.
Of course, it's a pleasure.
So, tell us something about yourself and OpenMind.
Oh, well, I've been fascinated by robots and robotics since I was a little kid. I'm sure that's true of many of your listeners. Uh, we probably, as we were growing up, we read these stories and watched movies with robots being useful, exploring the world and space, and being smart. And finally, it seems like key parts of that tech stack are being realized. And it's just a fascinating moment to be in tech and robotics right now.
So that's very cool. So, you established the company about a year ago.
Yep.
And what's the vision behind OpenMind?
Well, the vision is that we see the technology moving extremely quickly. And most people don't realize just how quickly the technology is moving. Robotics for a long time was a little bit stuck in the sense that people were focusing on like basic movement and not falling over. And now all of a sudden, with large language models, you can add a whole other level of capability that relates to making good decisions and
Right.
navigating new spaces and teaching my 13-year-old math.
Nice.
And that's something that even a few years ago would have been really hard to imagine.
Yeah.
But now all of a sudden you can do it.
Hmm.
And as the technology is coming together that quickly, it's important for a lot of people to know about that.
Right.
And it's also important, personally speaking, to build that software in a transparent, open way. I don't want to wake up in a world where I'm surrounded by machines
Right.
that are extremely capable, extremely smart, and I, as a human, have no good ability to peer inside their brain and have a fighting chance of understanding what they're doing and how they're doing it.
Right.
And that's why we're building a open source software. And it may sound kind of crazy if you're writing software for thinking machines,
Mhm.
why on earth would you open that up?
Right.
But we have like really strong opinions about that. We think it's critical that those kind of technologies are out in the open
Hmm.
so that everyone can see them and hopefully everyone can also contribute, as opposed to just living in a world surrounded by thinking machines.
Right. And what kind of software do you offer? Is it you you mentioned this as an operating system
Yep.
for general purpose robotics. Right now, what are you offering to anyone who wants to develop
Ah,
robotics?
well, like a general purpose operating system for robotics, that's a big topic area.
Right.
For example, Iris right here is running 3 computers right now.
Mhm.
One computer is just for motion. The other computer is for making sense of different sensors like LiDAR.
Mhm.
And then the third computer, the Mac Mini, is dealing with local inference and preserving privacy where possible and connecting to the cloud with 8 other large language models that are all working together to make good decisions about what to say, what her emotions are right now,
Right.
and how she's interacting with humans. So the notion of OM1 being like the operating system for humanoids, that's really not that accurate in the sense that there's so many other things going on.
Okay.
For example, it would be crazy for us to try to rebuild everything ourselves. And we're very lucky that there are hundreds of companies in robotics
Hmm.
that are building things like foundation models for arms.
Hmm.
So we can treat that as a modular capability, and we can just use someone else's model or technology for that. So what our software does, rather than trying to reinvent the wheel, it's a framework that makes it very easy for people to put together different large language models and different capabilities and coordinate those things. So it's the point of the software is to make it very easy to add and remove functionality, and wrap it together in a convenient way. In terms of what the software does right now, um, we've chosen to focus primarily on robot-human interactions.
Okay.
So our software is horrible for things like ballet dancing or backflips
Hmm.
or assembling iPhones. Instead, what we've really been emphasizing are making humanoids interesting and funny,
Mm.
and having them make good decisions about what to do next, and to collect data that helps them learn about the world around them. So we've completely de-emphasized fine motor skills.
Okay.
So if you want to build a neurosurgeon humanoid, do not use our software.
Mm.
If you want ballerina dancing, backflipping robots, other people are much better at that than we are. But when it comes to reusing existing models and stitching them together in a really easy, convenient way,
Okay.
that's what we're trying to make possible. In terms of when people come and buy humanoids with our software on it, the three things those humanoids will come when you unbox them in your house, they will come with basic tutoring capabilities. So, for example, if your kids have questions about their math homework, they
Okay.
can just ask Iris, hey, Iris, come over here, help me with my homework.
Hmm.
So that's an education tutoring capability. The other thing is the ability to help uh, elderly parents who live at home.
Okay.
For example, my mom recently fell and got stuck underneath the dining room table,
Oh,
and I'm many thousands of miles away. And what I really would have liked in that situation is to have something in her house that, if she's gone for a while, we'll go look for her
right.
and then immediately make it possible for her to speak to a doctor or speak to a family member through a really simple like voice interface or like a Zoom-like experience. And so the second capability is really focused on being a sort of safety or health focused companion in the home.
I see.
And the third use case that a lot of people seem to want, especially for our quadruped dogs, the first thing they want the quadruped dog to be able to do is bark when it sees people who are new. And that's
Really?
a little bit like a safety, security type capability. So if your quadruped lives in your home, people expect it to be able to recognize new people and bark if they haven't seen that person before. And that's a little bit of like a security type functionality that most people who have dogs just associate with having a dog at home, is that it will bark when it sees something new or scary.
Okay. So is the same system going to evolve to be doing useful tasks, maybe at home or maybe at commercial settings?
Yeah, that's certainly the dream, I think, in robotics, is that robots are capable, but just really useful and convenient. And we think of that as a moving approximation in the sense that we know there's certain things humanoids can do today
Right.
that are useful, but we expect continuous software upgrades
Mm.
that over time make them more and more useful. And however, there's a big problem we've seen. And the big problem is that when a lot of people think about what a humanoid should do in their home, they gravitate to things like picking up socks and putting them in the washing machine, or doing the dishes,
Right.
or mopping the floor. And that's, for a humanoid right now, incredibly difficult.
Hmm.
Imagine having to wet wipe a floor. There's water and it's slippery and there's soap, and it's just incredibly difficult to do
Right.
that now. So those kind of tasks like wet wet wiping your floor, that's going to be a long time. But many other tasks that people don't normally associate with the humanoid in their home,
Hmm.
those ironically turn out to be much easier.
Okay.
Like giving my 13-year-old the ability to sit down at the kitchen table and talk to the humanoid about middle school math. in a
Hmm.
useful way.
I see.
So right now, there's still a big mismatch between what most people think the humanoid will do in their home compared to what humanoids today are capable of, health-focused use cases, security monitoring
Mhm.
focused use cases, teaching, tutoring,
Okay.
education type things. And that's going to be the first wave of actual capability.
Okay.
And the whole business about, your humanoid picking up your socks and putting them in the washing machine
Right.
or wet wiping your floor, are going to be the last type of capabilities to be rolled out into the home.
Right. And how are you thinking about so humanoids have limited compute, the GPU capacity. You are thinking more of a modular approach, unlike other companies who want to make huge models and
Yeah.
run them on board.
Well, there's nothing wrong with huge models.
Hmm.
Huge models can be amazing if your robot has a static architecture
Hmm.
and your robot has a static um, task to accomplish. For example, if you're building software for robotic cars like Waymo, then you're not going to wake up in the morning and your car is going to have 3 wheels or 8 wheels
Right.
or a tail or wings.
Right.
So
It's a
that,
bit windy here.
yeah, it's a bit windy and she's getting bored. Um, that your car has 4 wheels.
Mm.
And the whole task of the model is accelerate, brake, turn left, turn right. That's
Mm.
it. And for that kind of situation, an end-to-end model can be perfect.
Right.
The problem really comes when capabilities or sensors are suddenly added and removed to a robot,
Right.
or like a gripper arm is added,
Hmm.
or you add a totally new type of sensor. And then if you've built this monolithic end-to-end AI model, it can be very difficult to change it and quickly accommodate new capability.
Right.
If you build your software in a modular way,
Right.
um, you're then able much more quickly to accommodate changes of geometry or
Hmm.
changes of task.
Okay.
And imagine a Waymo, I attach wings and say, now go fly.
Okay. Yeah.
If you have an end-to-end AI model trying to do this, well, then it's this very slow, costly process of building a aviation end-to-end AI.
Mm.
But if you have a sort of modular stack, you can imagine removing the wheels and adding the wings
Mm.
as like Lego-like plugins. The companies that are have a very similar perspective are Google's Intrinsic,
Okay.
and they explicitly have this notion of a Lego-like set of capabilities
I
that
see.
can be snapped together to create a good software for a particular form factor and task. And we 100% agree that's probably the way of doing things. The other thing that this modular architecture gets you is you have an infinitely easier time debugging.
Okay.
Because if the robot does something, you say, why did you just do this?
Mm.
If you have all these different modules that are communicating in an intelligible way, you can now go back into the log files and
Okay.
figure out exactly where the issue was. It's not like an end-to-end model that all of a sudden has unexpected output and you have no idea where in the weight matrix is stored this unexpected behavior.
Right.
So we find it makes intelligibility easier, it makes debugging easier, and it gives you a easier to reconfigure robot.
Your background is also bioengineering.
Yeah,
Right.
so I'm a complicated character because I've always loved engineering and physics and computers,
Right.
and then I became a physics professor
Okay.
at UC Berkeley. But then I got interested in building things that lots of people think are useful. So for some reason, I got addicted to this notion of working on problems that lots of people around me, this is incredibly windy, that lots of people around me think are useful.
Right.
And I was really tired of writing papers where I would get a paper critique on Christmas Eve saying, Jan, you got the citation order incorrect. So I wanted to work on problems that where just lots of people around me think that they're useful. That then brought me to bioengineering and healthcare.
Right.
And my specific interest there is computing on sensitive data in ways that respect privacy.
Okay.
And just to give one example, imagine there was such a thing as a healthcare AI available globally
Right.
that also had the property of being completely private.
Okay.
So you could ask it questions, you would get good responses, it would be available at very low cost, and your information wouldn't be leaked to insurance companies or search engines or whatever. So that would be an example of something I care about in the healthcare space. But I thought it was interesting, like a year or two ago, to just deploy some quadrupeds and humanoids into my home and just see what happens. And that then led to being forced to write a software stack
Okay.
to make the machines in my home useful and capable. And then it seemed obvious to take all of that and just open source it
Okay.
so that everyone can do the same in their homes or workplaces.
That's great. And what can people who want to develop on your open source platform? How can what all they can do?
So the biggest problem right now is that there are very few humanoids in the US.
Right.
So if you're a developer and you say, "Oh, this is awesome. Where do I get a humanoid?"
Right.
Then you immediately run into lots of problems with they're still super expensive and they're still super rare.
Mm-hmm.
But fortunately, that's beginning to change. There are companies like Payscale who are working on making themselves affordable. And Hugging Face has also just announced one or two affordable humanoids. So right now, if you're a developer who wants to write software for humanoids, unfortunately, it's very difficult simply because access to the hardware is still so limiting.
Right.
But that's going to change dramatically over the next 9 months. And for example, at Hugging Face, you can already buy a good gripper arm.
Right.
So developers should anticipate a wave of affordable, highly capable humanoid quadruped or gripper arm hardware they can actually buy. So we're still a few months ahead of that wave,
Okay.
but that's something we're very much preparing for. What we're doing practically to alleviate this problem is build out the simulation side. So the idea is that you can start building software now in a simulated world, and then once this wave of hardware becomes more accessible in the US, then you can just deploy what you've built in the simulated world onto the actual hardware platform. But again, that transition is at least 6 to 9 months away.
Right. Very cool. Thanks for having me here.
Oh, this is a
Yeah.
blast.
Yes.
You're welcome anytime. We'll soon have a drop-in clinic for robotics in San Francisco. So all of our neighbors are encouraged to drop by, play with humanoids, play with quadrupeds, get familiar with them. And we really want to demystify the technology.
Mm-hmm.
This is not some kind of space age obscure stuff in some lab
Right.
somewhere. Humanoids are here, not necessarily in the US, it's
Mm-hmm.
still super early, but that wave is coming.
Right.
And so drop by our little coffee and weekly workshop and just help us build the tech.
And have an open mind.
And have an open mind. You're absolutely right.
Thanks for having me.
This has been a
Yeah.
blast. Thank you.